welcome to 1 Degree of Sky Time. This is John Taylor, and I am very glad to be with you today as we do a two-part series talking about one of the most important things, I guess, on the surface of the Earth that we can notice, which is the ecliptic. So what does that mean? And we're going to start off with part one, and after that we'll move on to a better discussion, which ought to lead us into, as we're heading to the fall equinox, what that means, and then the winter solstice, what does that mean also? So this is a unique program I'm using, which is available from NASA. This is Eyes on the Universe, Eyes on the Solar System this time, and it's available at eyes.nasa.gov. So Eyes on the Solar System allows us to actually look at our solar system, and it's giving us nice traces of all the planets. That's what those rings are, going around our central sun right there in the middle. What I can do here is I can come up along, and we can see that our solar system is like a pancake. It's just a big flat line there. That pancake defines the ecliptic. What's really neat about this, if I can zoom in through the planets here, I'm going to try to, let's get on the Earth here. So I'll go ahead and click on the Earth and see if it'll zoom me in here. If not, I'll come in manually. Let's get on into where the Earth is, with the moon going around it. And I'm going to try to bring it up. I always have to go backwards on this one. There we go. Okay, so I hope you're not getting dizzy out there, but I'm looking at the Earth-Moon system. I'm going to bring it right in to where the Earth is. And let's zoom in and take a look. One thing you'll notice about the Earth is that north and south, you're going to see here, it's a little bit of a tilt to it. If I were to look around our Earth and start spinning it around, so I'll bring the part that I'm familiar with in the North America here. Let's get on past Asia. There's Africa. There's Europe. Let's keep going. Let's keep going. Also nighttime going on there. You can tell I'm doing this in the evening because we definitely have some darkness here in Indiana anyways. But you can see if I try to bring this around, oh my word, there's a little bit of an angle to this. That there's a little bit north and south are at a bit of an angle from what is up and down. And that could be partly due to my display, but that's actually part of how our Earth is. It's got about a 23.5 degree tilt to this. So you think straight up and look sideways and split that in half, that's 45. Then do that again, and that's about how much our Earth is off on axis. A lot of people think that this Earth tilt, as the Earth wobbles around a northern point here, that gives us our seasons. That's really just the opposite of what does happen. Since the Earth is so massive and it's spinning, it's more like when you ride your bike. Once you get those wheels spinning, the bike doesn't want to fall down. Those wheels want to stay like they are. And our Earth wants to stay at this tilt. So this makes something else happen in terms of our seasons, but I wanted to focus more right on today about the ecliptic. We'll talk more about that next time. The next thing to think about too is the curvature of this Earth means where you are on the Earth makes a difference on how you look at that pancake, that ecliptic. So if I'm on the equator, right there in the middle of the Earth, when I look out, the ecliptic is right overhead all the time. If I'm at the North Pole, I'd have to look sideways to see it. Yeah, we're at Indiana about halfway, so we have to look at about a 40-degree angle to see the ecliptic from where we are. And that makes quite a difference. So if I switch over here to Stellarium, wonderful program, also available free for people to use. And I start to look at our sky. What I'm going to do is I'm going to speed things up a little bit, and we'll see that as the sky rotates across, well, there's all these things going across. Well, there's the sun. Here comes the planets. Everything is moving around this line. The planets, sun, all of these are on what we call the ecliptic. So it's a neat place to find planets, to find the sun. If I'm looking for various stars, I look wherever they are because they're not necessarily on that ecliptic, but these things definitely are. So a quick lesson here about the ecliptic and how this works. I hope that makes a little bit of sense, and we'll go from that next time as we start to talk more about the equinox and talk about these solstices. Thank you for joining me. This again was John Taylor from the ETHOS Innovation Center. I'd like to big shout out to ETHOS Innovation Center. A lot of fun, a lot of exciting science happening here, engineering, technology, as we embrace mathematics and communications and make things happen. Also, if you like this program, you got to check out Science Stories. Miss Lisa does an awesome job with her stories. She reads various science stories of various ages for the young and young at heart. Also, big shout out to Michigan Astronomical Society. They do a great job of promoting astronomy, having star shows. Well, when we're past COVID, they'll be out again, I'm sure, if not sooner, and just making astronomy fun for everyone. This is ETHOS Innovation Center. Check us out at www.ethosinc.org, as well as on Facebook and our YouTube channel and Twitter. Have a great day. Thank you. Ad Astra.